Welcome to This Explainer. Today, we're diving into a phenomenon so incredibly ubiquitous that, honestly, we almost entirely take it for granted. Everything around us, from the baseball you casually toss in the yard to the Earth beneath your feet, all the way to the magnificent Milky Way galaxy, is constantly spinning. But why?
It seems like a pretty simple question on the surface, right? Why does everything in the universe spin? Well, answering this actually unlocks the absolute bedrock of physics, taking us all the way back to the very origin of reality itself.
Here's the crucial point. A universe without spin is literally impossible. It's not just some random cosmic accident or a quirky coincidence affecting stars and planets. It is a fundamental mathematical necessity for a stable, functioning cosmos. Without it, the universe as we know it simply could not exist.
To put this into perspective, just think about this. Even while you're sitting there completely still watching this explainer, you're actually moving at up to 1,040 miles per hour if you happen to be at the equator. That's literally faster than the speed of sound, all simply due to Earth's rotation. Now, you don't feel it because everything around you is moving at the exact same speed, but you are absolutely a fast-moving participant in this universal spin right this second.
Section 1. The Cosmic Figure Skater.
So, to understand how this rotation is born from massive, collapsing gas clouds in the early universe, we really just need to look at one bedrock principle of physics: the conservation of angular momentum. Basically, in any closed system, the total rotational momentum has to remain absolutely constant. So if a spinning object shrinks in size, it just has to spin faster to keep that momentum perfectly balanced.
Think of it like a classic figure skater pulling their arms in to spin faster and faster. 4.5 billion years ago, our solar nebula, which was massive, diffuse, and spanning light years across, started collapsing inward under its own gravity. And as it shrank, that preserved angular momentum forced it to spin wildly faster. The centrifugal forces pushed back against the collapse at the equator, which flattened this once spherical cloud right out into a dense, rotating protostellar disk. And that organized circular motion, that's exactly why planets were able to form in the first place.
Now, the distribution of all this spinning material was definitely not even. When our solar system formed, the sun basically hogged almost all of the available material, hoarding a massive 99.86% of the total mass. Just a huge cosmic vacuum. But check out this extreme contrast. While the sun has nearly all the mass, Jupiter alone holds about 60% of the solar system's entire angular momentum. It's wild, right? And why is that? Well, because angular momentum isn't just about mass or speed. It's heavily dependent on distance from the axis of rotation. Since Jupiter is so massive and orbits so incredibly far from the center, it practically holds the rotational reins of the entire solar system. But you know, Earth's spin isn't actually permanent. Tidal friction from the moon's gravity is creating this physical drag on our oceans, literally stealing Earth's rotational energy over time. Get this, 400 million years ago, a day on Earth was only 21.5 hours long. Obviously today, we're at exactly 24 hours, and it's continuing to slow down by about 1.7 milliseconds every century. So eventually, billions of years down the line, Earth is going to become tidally locked with the moon, meaning one side of our planet will constantly face the moon, forever.
Section 2. Black holes and extreme spin.
And man, it gets extreme really quickly out there. Just look at the number 716. In the most intense gravitational environments, when massive stars explode and their cores collapse into dense neutron stars, which are often just 10 miles across, by the way, their rotation accelerates drastically. Again, it's that same figure skater effect. They become pulsars, sweeping these intense beams of radiation across the cosmos as they spin. The fastest known pulsar actually rotates a mind-bending 716 times a second. That means its surface is moving at a significant fraction of the speed of light. Rotating black holes take this to a whole other level. They don't just sit there in space. They literally twist the fabric of space and time around them as they spin. It creates this totally bizarre zone called the ergosphere right outside the event horizon. Inside the ergosphere, space itself is being dragged so aggressively that absolutely nothing, not even light, can stand still. You're literally forced to move in the direction of the black hole's rotation. Oh, and the singularity inside, it isn't a single point anymore. It's actually stretched out into a rapidly rotating ring. But here is what is truly mind-blowing to me. This whole frame-dragging effect isn't just some deep space theory reserved for massive black holes. Back in 2004, NASA's Gravity Probe B proved that our very own Earth's rotation also drags space-time.
It twists it by a tiny 39 milliarc seconds every single year. So, right at this very moment, as the Earth spins, it is literally dragging the fabric of the universe along with it.
Section 3. Spin at the quantum level.
All right, now this is where things get a little bit weird as we scale all the way down to the subatomic world to compare classical rotation with quantum spin. Fundamental particles like electrons don't actually physically rotate like tiny little baseballs turning in space. In fact, they have zero physical size. They're just point particles. But they possess this built-in intrinsic quantum property that we simply call spin. And the fascinating part is that this quantum spin acts mathematically exactly like classical angular momentum.
So why does this matter to you and me? Well, it all comes down to the Pauli exclusion principle. Because of this intrinsic quantum spin, electrons obey a critical rule. No two identical particles with half-integer spin can occupy the exact same quantum state. If particles didn't have this spin property, all electrons would just fall straight into the lowest energy level. Chemistry wouldn't work, atoms would just collapse into themselves, and matter as we know it simply wouldn't exist. Your very physical structure relies entirely on quantum spin. How crazy is that?
Section 4. The symmetry of reality.
Okay, so we've seen that everything spins on absolutely every single scale. But it begs the ultimate philosophical question, why? Why does this law of angular momentum even exist in the first place? Well, the answer is rotational symmetry. Back in 1915, the brilliant mathematician Emmy Noether proved something incredibly profound. She showed that every single symmetry in the laws of physics corresponds to a conservation law. Basically, conservation of angular momentum exists simply because our universe has rotational symmetry. It means the fundamental laws of physics do not change depending on which direction you face. Up, down, left, right. Physics is exactly the same. And because of that deep underlying mathematical symmetry, angular momentum has to be conserved, and so rotation persists.
And this perfectly explains the cosmic chain reaction that created the universe we live in today. Right after the Big Bang, you had these tiny, totally random quantum fluctuations. Those created minute velocity differences in the early gas clouds. Then as gravity slowly pulled all this matter together, it concentrated that initial momentum. So when you look at the breathtaking rotation of those magnificent spiral galaxies through a telescope, what you're actually seeing is just the accumulated, gravitationally amplified echo of those tiny, random, primordial quantum stutters.
Now, let's just imagine for a second a universe without this spin. It would be an absolute disaster. Gravity would just win, completely. Entire galaxies would collapse straight down into dense, supermassive black holes. The Earth's internal dynamo would just shut off, which would strip away our protective magnetic field and leave us completely exposed to solar winds. You'd have no stable planetary orbits to keep us warm, and our atmospheres would be totally stagnant. The entire cosmos would basically become a dead, uninhabitable void. So really, rotation is the essential outward force that successfully holds the entire structure of the universe up against the crushing weight of gravity.
Which brings us to a final, pretty profound thought for you to take away from this explainer. Are you just an echo of the universe's primordial spin? Seriously, think about it. Every single breath you take on this rotating rock, the weather patterns that grow our food, and literally every heavy element in your blood, which were all forged in the violently rotating hearts of dying stars, it's all the result of cosmic rotation. It really leaves us to wonder, is your very existence just the beautiful, inevitable consequence of a universe that simply never stops spinning?